This is a very typical velocity addition problem, a boat crossing a river. So the river has a certain speed, the water has a certain velocity, VWG, the velocity of the water with respect to the ground, because that's how we would measure the velocity of the water, right? With respect to the shore or the earth or the ground. And the boat measures its velocity with what it's moving through with respect to the water. And our boat is going to leave point A, and it's going to always be pointed directly across towards the other side. So I've drawn in here the velocity of the boat with respect to the water. But of course it's not going to end up at point B because the water's moving. Where is it going to end up? At point C. And what we want to know is what is that distance. I'm going to call that D. Given VWG, V boat water, and the width of the river, find the velocity of the boat with respect to the ground and the distance downstream where the boat ends up touching shore. Okay, let's put some numbers in here. The velocity of the water with respect to the ground, let's make that 4 meters per second. And that, I'll put a coordinate system in here. Let's call this our x direction, and up on the paper the y direction. So this is going to be in the x direction. The velocity of the boat with respect to the water, how about 10 meters per second in the y direction. The width of the river, what should we make it? How about 200 meters? And let's go ahead and find the velocity of the boat with respect to the ground and D. So the velocity of the boat with respect to the ground is going to equal the velocity of the boat with respect to the water plus the velocity of the water with respect to the ground. This is just using our master formula. The first subscript is the same, the last one is the same, and those two in the middle are the same. So this formula helps us keep track of the subscripts, makes us get it right if it's an addition problem or a subtraction problem, and which vector we're starting with and ending with. It just helps organize our thoughts. Let's draw a quick coordinate system. X, Y. So the velocity of the boat with respect to the water is proportional to 10. And the velocity of the water with respect to the ground, we're adding that vector. It's a little less than half. The resultant, I'll draw it in red, is the actual path, the boat with respect to the ground. That's the path of the boat as viewed by somebody standing on the shore. And does that match the blue dashed line we drew earlier? Yes. So we always want to go back and think about it, make sure it makes sense, make sure you added those vectors properly. So the first thing we want to do is find what that is. And this is already a right triangle. I gave you some easy ones. The velocity of the boat with respect to the water was already perpendicular to the velocity of the water with respect to the ground. So this is fairly straightforward. The velocity of the boat with respect to the ground, the magnitude of that is going to be 4. This side is 4. The other side is 10, and we're finding the hypotenuse. So 4 squared plus 10 squared square root. And we can find an angle. I'm going to put theta here. Theta is going to be the inverse tangent of 10 over 4. The first part's done. I found the magnitude and the direction, and now I'm ready to find what distance the boat drifted from point B. So does this problem remind you of something else? It's very similar to a projectile motion problem. Maybe you fire a projectile horizontally off a cliff and you want to know how far it lands away from the base of the cliff. So what's the thought process there? You break up the velocity of that projectile into x motion and y motion. You use the y motion to find how long it takes for the projectile to hit the ground. And then you use that time and the x velocity to find out how far away from the cliff it ends up. Here we're going to do the same thing. I'm going to use what I'm calling my y motion across the river. I know my speed in that direction. I know the distance, so I can find the time it takes to cross the river. And then I'm going to use that time and my x velocity to find out how much it drifts, just like a projectile motion problem. The time it takes to cross the river is going to equal the distance divided by the velocity. The distance was 200 meters, and in the y direction, the velocity across is 10 meters per second. So it takes 20 seconds to cross the river. And x final is v initial times time, because x initial is 0 and the acceleration in the x direction is 0. It drifts 80 meters downstream.